Some gemstones are rare because they're expensive. These are rare because you may never get the chance to see one at all. They come from exhausted deposits, isolated discoveries, and tiny pockets of rock that produced only a handful of exceptional specimens. Some now spend their lives behind museum glass. Others disappear into private collections almost as soon as they reach the market. You can study their photographs. You can know their names. You can even spend decades collecting gemstones and still never encounter a genuine example in person. Today, we're counting down 10 gemstones so difficult to encounter that most collectors may never see them with their own eyes. And the final stones are rare for reasons that price alone cannot explain. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Number 10. Grandidierite. The gem most people know only from photographs. If you've spent enough time looking at rare gemstones online, you've probably seen Grandidierite. That doesn't mean you've actually seen one. In photographs, the stone can look almost unreal. A cool blue-green somewhere between tropical seawater and the deeper tones of teal. But for most of its known history, transparent Grandidierite was something collectors could read about far more easily than they could actually find. The mineral was first described in Madagascar in 1902 and named after French naturalist Alfred Grandidier. Finding the mineral itself, however, wasn't the real problem. Finding material good enough to become a transparent faceted gemstone was. Most Grandidierite occurred as opaque or translucent material. Fine transparent rough was extraordinarily limited, which meant there was very little for cutters to work with, and even less reaching collectors as finished stones. For decades, that helped give transparent Grandidierite an almost mythical reputation. Then the story changed. In 2014, a new deposit was discovered near Tranomaro in southern Madagascar. When gem-quality material began reaching the market, collectors suddenly had access to something that had previously been exceptionally difficult to encounter. But there was a catch. Much of the recovered rough still wasn't suitable for high-quality faceting. Fractures, inclusions, and limited transparency reduced the amount that could become the clean, blue-green gems people saw in photographs. And even when good rough is found, Grandidierite presents another challenge. It's strongly pleochroic. Turn the crystal in different directions, and it can show different colors, from blue-green to green and nearly colorless tones. For a cutter, orientation matters. Cut the rough in the wrong direction, and you may sacrifice the very color that makes the gemstone desirable. So the supply narrows again, first from mineral to gem-quality rough, then from gem-quality rough to material worth faceting, and finally to finished stones with attractive color and transparency. That's why the internet can give a misleading impression of Grandidierite. Search its name, and you'll find image after image. Walk into ordinary jewelry stores, or even many gem shows, and the experience can be very different. You might collect gemstones for years without ever having a fine, transparent example placed in your hand. And Grandidierite is only number 10. Because the next gemstone presents an even stranger problem. Even if one were sitting in front of you, there's a good chance you wouldn't know what you were looking at. Number 9. Jeremejevite. In 1883, an unusual group of crystals was identified from Mount Soktuj in Siberia. They were small, pale, and hardly the kind of discovery that would attract the attention given to diamonds or rubies. But they represented something new. The mineral was named Jeremejevite, after Russian mineralogist Pavel Jeremejev. And for more than a century, that name was far easier to encounter than the gemstone itself. The situation changed dramatically in the late 1990s, when gem-quality Jeremejevite was discovered in Namibia. Later finds in the Orongo Mountains produced beautiful crystals, including transparent material with the delicate blue coloration now strongly associated with the species. For collectors, this was a major discovery, but it didn't make Jeremejevite common. The productive pockets were limited, and only part of the recovered material had the transparency and quality needed for fasting. That's an important distinction. A photograph of a spectacular Jeremejevite crystal doesn't mean that crystal could produce an equally spectacular gemstone. Natural crystals may contain fractures, inclusions, or internal features that dramatically reduce the amount of usable rough. And sometimes cutting isn't desirable at all. A well-formed natural Jeremejevite crystal can be valuable as a mineral specimen. Destroying it to produce a much smaller faceted stone may actually reduce what makes the specimen special. So the already limited supply divides into two worlds: crystals preserved for mineral collectors and rough sacrificed for faceted gems. There's another problem. Jeremejevite doesn't necessarily look extraordinarily rare. Fine examples can be colorless, pale yellow, or a delicate blue. Without a label or laboratory report, a small faceted Jeremejevite may not immediately stand apart from other lightly colored gemstones. That's why identification and provenance matter so much. At this level, collectors aren't simply paying for beauty. They're paying for confidence that the stone really belongs to an unusually scarce mineral species, and the internet can distort that scarcity. Search for Jeremejevite and you'll find dozens of photographs within seconds. But those photographs don't represent dozens of new deposits. The same important specimens can appear again and again. In the physical world, the situation is very different. A collector could spend years visiting jewelry stores and gem shows without ever handling a confirmed, fine-quality faceted Jeremejevite. And that's only number 9. Because the next gemstone demonstrates something even stranger. It was so difficult to distinguish from another gem that the first recognized example had already been cut and mistaken for spinel. Number 8. Taaffeite, the gemstone hiding in plain sight. Imagine buying a spinel, only to discover that the stone in your hand is a gemstone science didn't even know existed. That's essentially how Taaffeite entered the gem world, and it raises a fascinating possibility. How many Taaffeites had already passed through people's hands without anyone recognizing them? The answer may never be known. In 1945, gemologist Richard Taaffeite purchased a group of already cut stones from a jeweler in Dublin. They were believed to be spinels, but while examining them, Taaffeite noticed something that didn't fit. One stone showed double refraction. Spinel shouldn't do that. The specimen was investigated further, and eventually came the remarkable conclusion: this wasn't an unusual spinel. It represented a previously unrecognized mineral species. It would later be named Taaffeite. That origin story is important because Taaffeite doesn't necessarily look like something extraordinary. It can occur in subtle pink, mauve, violet, and purplish tones, colors that can overlap visually with other gemstones. Later discoveries, particularly in Sri Lanka and Myanmar, produced additional material. But fine faceable Taaffeite remains scarce, and that creates a problem most collectors don't face when buying familiar gems. Suppose you find a beautiful purplish stone at a gem show. The seller says it's Taaffeite. It looks right. The color seems right. The price certainly suggests something rare. But none of those things proves what it is. With Taaffeite, identity is part of the value. A similar-looking spinel may still be beautiful, but it's an entirely different mineral. That's why serious examples often need reliable gemological testing and documentation. And there's an even stranger effect created by the internet. Taaffeite doesn't feel impossibly rare when you're looking at a screen. Search the name and photographs appear immediately. Dealer listings appear, articles appear, auction records appear. But digital visibility isn't physical availability. The same limited population of stones can circulate through photographs, collections, dealers, and publications for years. A collector could therefore know exactly what Taaffeite is, study its properties, recognize its history, and still never knowingly handle a confirmed specimen. And that brings us to number 7, because if distinguishing Taaffeite from ordinary-looking gemstones already sounds difficult, the next stone makes the problem even more interesting. It belongs to the same mineral group. For years, it carried an almost legendary reputation for rarity, and sometimes determining whether you've actually found one requires technology that goes far beyond a jeweler's loupe. Musgravite. Number 7, Musgravite, the gem that needs proof. A dealer can call a gemstone Musgravite. A collector can pay for it as Musgravite. It can even sit in a collection for years under that name, and it can still turn out to be something else. That's what makes Musgravite such a fascinating challenge. The problem isn't simply that it's rare, it's that Musgravite belongs to the same mineral group as Taaffeite, the gemstone we just saw, and separating closely related members isn't always something you can do by appearance alone. Musgravite was first identified from the Musgrave Ranges of South Australia in the late 1960s. But the early material wasn't the beginning of a thriving gemstone market. For years, faceable examples remained exceptionally difficult to encounter. Eventually, gem-quality material was reported from other localities, including Sri Lanka and Myanmar. Yet another problem remained. A faceted musgravite can look surprisingly ordinary for something so uncommon. Depending on the specimen, colors may include grayish, greenish, brownish, violet, or purplish tones. There's no single visual signature that immediately tells a collector, this is musgravite. And because its properties can overlap with Taaffeite, confirming the exact mineral can require advanced laboratory analysis. GIA, for example, has examined tiny stones believed to belong to this group where techniques such as Raman spectroscopy were needed to establish their identity. Think about what that means for someone walking through a gem show. You could have a loupe, you could understand gemstones, you could have decades of collecting experience, and you still might not be able to confirm what you're holding. That's a very different kind of rarity. A spectacular Paraíba tourmaline announces itself with color. A fine alexandrite can reveal itself through dramatic color change. Musgravite may give you no such moment. Its importance can remain invisible until the science is done. And this is why old claims about musgravite need to be treated carefully. You'll sometimes encounter dramatic statements saying only a tiny fixed number of stones exist. But new discoveries and improved identification can change those numbers. The stronger point isn't an outdated statistic. It's that confirmed gem-quality musgravite remains a specialist collector stone, and reliable identification matters enormously. So most collectors face two barriers. First, they have to encounter one. Then they have to know that it's actually real. And number 6 presents almost the opposite story. It began as a mineral represented by crystals so small that faceted gemstones seemed almost irrelevant. Then, thousands of miles from where it was first recognized, miners uncovered material that changed its story completely. That gemstone is Poudretteite. Number 6, Poudretteite, the gem that appeared twice. For decades, Poudretteite had one serious problem as a gemstone. The crystals were simply too small to matter. The mineral had been found during the 1960s at Mont Saint-Hilaire in Quebec, Canada, a locality famous for unusual minerals. But the early crystals were tiny. For mineralogists, that was enough. For someone hoping to cut a beautiful gemstone, it wasn't. Poudretteite remained essentially a mineralogical curiosity, and in 1987 it was formally recognized and named after the Poudrette family, whose quarry was associated with its discovery. If the story had ended there, most gemstone collectors might never have heard the name. But decades later, something completely unexpected appeared on the other side of the world. In Mogok, Myanmar, miners recovered transparent crystals that didn't fit comfortably with the gemstones they already knew. This time the material wasn't microscopic. Some of it could actually be faceted. When the stones were studied, the result connected two places separated by thousands of miles. They were Poudretteite. Suddenly, a mineral known from tiny Canadian crystals had become a genuine faceted gemstone. And some of the material was beautiful. Fine Poudretteite can show delicate pink to purplish pink coloration, sometimes with enough transparency to produce elegant finished stones. But this wasn't the beginning of a new mass-market gem. The supply remained extremely limited compared with familiar colored stones. And there's another reason Poudretteite fits this countdown so well. It doesn't look impossible. If someone placed a small pink Poudretteite beside several other pink gemstones, most collectors couldn't identify it simply by sight. It doesn't have one famous visual effect that immediately reveals its identity. What makes it extraordinary is the mineral species itself and the remarkably limited geological circumstances in which gem-quality material has been found. That makes documentation especially important, because when rarity is invisible, a name on a dealer's tray isn't enough. But Poudretteite also teaches us something more important about rare gemstones. Rarity can change overnight. Before the Myanmar material appeared, the idea of faceting significant Poudretteite would have seemed almost unrealistic. Then one discovery rewrote what collectors thought was possible. That's why claims like only a few exist should always be treated carefully. The Earth doesn't care about our rarity rankings. Tomorrow, another pocket could be discovered, or perhaps nothing significant will appear for decades. For collectors, that uncertainty is part of the fascination. Poudretteite went from tiny Canadian crystals to transparent pink gemstones from Myanmar because someone happened to dig into the right piece of earth. But number 5 is different. You already know its mineral family extremely well. You've seen it in green. You've seen it in blue. You've probably seen it in pale pink. But nature also produced it in a color so unusual and in so few important places that many collectors may never encounter a fine example in person. Red beryl. Number 5. Red beryl, a familiar mineral in an almost impossible color. Most collectors have already seen this mineral family. Green beryl gives us emerald. Blue beryl gives us aquamarine. Pink beryl gives us morganite. But nature also produced beryl in a far less familiar color. Red. And that's where the supply becomes dramatically smaller. Red beryl was first discovered in Utah in 1904 by mineralogist Maynard Bixby. But those early discoveries didn't create a meaningful supply of faceted gemstones. The source that would become most important for gem-quality material was later found in Utah's Wawa Mountains, particularly at the Ruby Violet claim. The reason fine red beryl is so difficult to encounter begins with geology. It formed in an unusual volcanic environment associated with rhyolite, where the right combination of conditions allowed manganese to contribute its distinctive red coloration. But forming red beryl was only the first hurdle. The crystals were commonly small and could contain fractures and inclusions. So only a fraction of already uncommon material had the quality needed for faceting. Then cutting reduced that supply again. A promising crystal in the host rock might produce a finished gemstone weighing only a fraction of its original size. That's why judging red beryl by the standards of more familiar gems can be misleading. A 1-carat ruby doesn't sound particularly large. A fine red beryl approaching or exceeding that size is a very different proposition. And unlike ruby or sapphire, there hasn't been a broad network of major deposits supplying the market from multiple countries. Fine red beryl has remained tied to an extremely restricted geological story. That's what a photograph fails to communicate. On a screen, a red beryl may simply look like another small red gemstone. A ruby might appear more saturated. A spinel might look brighter. A garnet might be dramatically larger. But rarity isn't something a camera can show. The extraordinary part is that this familiar mineral family produced transparent red material of faceable quality in such limited circumstances. So a collector might own emeralds from several countries, aquamarines in multiple colors and sizes, and an entire tray of beryl specimens, without ever handling a fine faceted red beryl. And now the countdown becomes even more restrictive. Because number 4 is also tied to the American West. It's blue, exceptionally brilliant, and came from a source so geographically limited that one small area in California became inseparable from the gemstone's identity. Benitoite. Number 4. Benitoite, the blue gem trapped in one corner of California. There are blue gemstones found across the world. Sapphire comes from multiple continents. Blue tourmaline appears in several geological environments. Aquamarine has been mined from Brazil to Africa and Asia. Benitoite never had that luxury. Its story became tied to one small region of California. In 1907, blue crystals were discovered in San Benito County, in material that initially appeared similar enough to sapphire to cause confusion. But these crystals weren't sapphire. They represented a mineral that had never been scientifically described before. It was named Benitoite after the county where it was found, and visually it had everything a gemstone needed to become famous. Fine benitoite can show an intense blue color, sometimes with violet undertones. It also has unusually strong dispersion, the ability to separate white light into spectral colors. In a well-cut stone under the right lighting, flashes of colored fire can appear against the blue body color. So why don't collectors see benitoite everywhere? Because the geology that created it was extraordinarily localized. The most important source, later known as the Benitoite gem mine, produced the crystals that established the gemstone's reputation. But even there, finding benitoite didn't mean finding faceable benitoite. Many crystals were small, others contained inclusions or fractures, and some of the finest natural crystals had another kind of value entirely. They were worth preserving intact. That's an unusual problem in the rare gem world. A beautiful Benitoite crystal can be highly desirable to a mineral collector. Cutting it might produce a brilliant gemstone, but it also destroys a natural crystal specimen that can never be recreated. So limited material effectively competes between two groups: those who want the crystal exactly as nature made it, and those who want the fast-setted gem hidden inside. The result is that fine-faceted benitoite, especially in significant sizes, can be far harder to encounter than online photographs suggest. And since commercial production from the historic source is no longer what it once was, collectors largely depend on material already recovered and circulating through existing collections and dealers. California recognized benitoite as its official state gemstone in 1985. But even in the state whose name is permanently linked with it, most people will never see a fine-faceted example outside a museum, specialist collection, or gem show. And now we've reached the final three. At number 3, rarity becomes even harder to measure, because this next gemstone became famous for a claim repeated around the world, that only a handful of specimens existed. Then miners found more. The old numbers became obsolete almost overnight. But even after that discovery, Painite remained a gemstone most collectors may never encounter in person. Number 3, Painite, the gem that outlived its own rarity legend. For years, Painite carried one of the most powerful labels in the mineral world, one of the rarest known gemstones on Earth. The claim wasn't marketing. For decades, there was almost nothing to collect. The story began in Myanmar in the 1950s, when British mineral dealer Arthur C.D. Payne acquired unusual brownish-red crystals. At first, they were reportedly thought to be something more familiar, but laboratory examination revealed that the material represented a previously unknown mineral. It was named Painite after Payne. And then something extraordinary happened. Almost nothing. For years, additional specimens were extraordinarily difficult to find. Painite became the kind of mineral many collectors knew from books rather than display cases. Its reputation grew precisely because its physical presence was so limited. If you collected gemstones during that period, owning one wasn't simply a question of having enough money. There had to be a specimen available in the first place. Then Myanmar changed the story again. New Painite-bearing localities were discovered, and significantly more material began to emerge. Suddenly, the famous old statements about only a tiny handful of known specimens were no longer accurate. Painite hadn't become common, but its legendary rarity had to be rewritten. And that's what makes it more interesting than the old numbers. Painite shows that rarity is not permanent. A gemstone can spend decades near the edge of scientific knowledge, then one new pocket in the ground can change what collectors believe almost overnight. Yet there's another catch. More painite does not mean more fine-faceted painite. Much of the material can be heavily included, fractured, dark, or better suited to mineral specimens than transparent gemstones. The attractive face table portion represents a much smaller part of the total supply. And visually, painite doesn't advertise its reputation. It can appear reddish-brown, brownish-red, or deep red, colors that could remind an observer of several far more familiar minerals. Without identification, you might never guess the history behind the stone. That's why most collectors still won't casually encounter fine painite while browsing an ordinary jewelry store. You have to enter the specialist world where mineral identity matters as much as beauty. And painite leaves us with perhaps the most important lesson in this countdown. Never assume today's rarity record will survive tomorrow's discovery, because number 2 takes us even closer to that boundary. A gemstone so uncommon in transparent face-table quality that simply recognizing one can require far more than knowing what color to look for. Serendibite. Number 2, Serendibite, the gem rarity you could easily overlook. If a rare gemstone were sitting in front of you, would you know? With Serendibite, probably not. There is no single famous color that gives it away, no dramatic optical effect, and no visual shortcut that allows an ordinary collector to look across a gem show counter and confidently identify it. That's part of what makes transparent gem-quality Serendibite so difficult to encounter. The mineral was first described in Sri Lanka in 1902, and its name comes from Serendib, an old name associated with the island. But the existence of the mineral itself isn't what puts Serendibite this high on the list. The real bottleneck is finding material suitable for fasting, Much serendibite occurs as dark or opaque material. Transparent crystals capable of producing attractive finished gemstones are a completely different proposition. Gem-quality material has been associated with Sri Lanka and later with Myanmar, but supply has remained highly restricted compared with familiar collector stones. And when transparent material does appear, identification becomes critical. Serendibite can occur in blue-green, greenish-blue, and very dark tones. Those colors aren't exclusive to serendibite. So a small faceted stone can be visually impressive without revealing anything about how unusual its mineral identity actually is. This is where rare gem collecting begins to separate from ordinary jewelry buying. At a jewelry counter, beauty can dominate the decision. At this level, proof becomes part of the gemstone. A collector needs confidence that the stone isn't merely similar in appearance to serendibite, but that its optical and chemical properties actually confirm the species. And there's another reason photographs can create the wrong impression. Search for an exotic gemstone online, and you'll often see multiple images immediately. Different angles, different dealers, different websites. It can feel as though examples are everywhere, but digital repetition isn't geological abundance. The same small population of unusual stones can appear repeatedly across the internet while remaining extraordinarily difficult to encounter physically. That's why serendibite fits number 2. Not because no specimens exist, not because another deposit could never be discovered, but because the transparent, faceable material collectors actually hope to see represents only a narrow fraction of an already unusual mineral. A collector could spend decades studying rare gemstones and never knowingly hold a confirmed fine serendibite. And yet, there is still one gemstone on this list that makes even that level of rarity seem almost accessible. Because with number 1, we're no longer talking about a gem represented by a small commercial supply. We're talking about a mineral species whose scientific story was built around one known faceted specimen. One stone, Taaffeite. Bon, red diamond. Most people don't think of diamond as something they may never encounter. Diamonds are everywhere. Jewelry stores display them by the hundreds. Auctions sell extraordinary examples every year. Museums place famous stones beneath carefully controlled lights. But natural red diamonds belong to a completely different world. Their rarity isn't simply about being expensive. The problem begins with how extraordinarily uncommon their color is. Unlike many colored gemstones where trace elements can produce familiar hues, the color of many natural red diamonds is associated with distortions in the diamond's crystal structure. That means the Earth had to do far more than create a diamond. It had to create the right structural conditions inside that diamond to produce an intense red appearance, and very little material reached the market. Australia's Argyle mine became famous for producing pink and red diamonds, but even among its enormous output, true red stones represented only a tiny fraction. Then the Argyle mine closed. That didn't make every red diamond suddenly disappear, but it removed one of the world's most famous sources of strongly colored pink and red diamonds from active production. And size makes the situation even more extreme. Many important red diamonds are surprisingly small compared with famous colorless diamonds. A stone weighing well under a carat can still attract enormous attention simply because confirmed natural red color is so difficult to find. That's why photographs can be misleading. Search online and you can see red diamonds within seconds. Auction photographs, museum photographs, dealer photographs, magnified laboratory images. But seeing images of rare diamonds isn't the same as encountering one across a counter. Many collectors may spend their entire lives seeing diamonds, without ever seeing a significant natural red diamond in person, and that is why it belongs at number 1. The rarest gemstone experience isn't always discovering a mineral whose name you've never heard before. Sometimes, it's discovering that one of the world's most familiar gemstones can exist in a form almost nobody ever gets to see. And that's what makes these gemstones different from simply being expensive. You can save for a diamond. You can search for the right sapphire. But some gemstones are so restricted by geology, discovery, and sheer availability that even knowing they exist doesn't mean you'll ever see one with your own eyes. And the list may not stay the same forever. Painite became less elusive when new deposits were found. Grandidierite became more accessible after new gem-quality material appeared. Tomorrow, another discovery could rewrite everything we know about one of these stones, or reveal a gemstone we've never seen before. So if you could see just one gemstone from this countdown in person, which would you choose? Let me know in the comments. And if you enjoy discovering the rarest stories hidden inside the earth, subscribe, because sometimes the greatest gemstone discoveries are the ones we haven't made yet.